Good afternoon, my YouTube viewers. In this video, what we're going to talk about is a nonparametric test. And a nonparametric test is a test that you perform where the data does not form a normal distribution. And so that's why that's what you have nonparametric tests for. So what we're going to do to demonstrate this nonparametric test, we're going to talk about patients that they're going to have a standard treatment and they're going to have a new treatment. And then we're going to calculate the difference between the standard treatment and the new treatment. And then we're going to assign it a sign. So the first thing that you have is you have your patients 1 to 10. So you've got 10 patients. And then you've got the standard treatment, which is just some values that I made up. And then you've got the new treatment, which is some more values that I made up. And then so the difference between then you have to calculate the difference between the new treatment and the standard treatment. And it's going to be either a positive number, a zero, or a negative number. And then what you have to do is you have to assign to the difference. So if D equals 0, if D2 equals 0, comma, and it's ifs, not one if, but ifs. If D2 equals 0, then it's going to be J20. And so, and then if D2 is greater than 0, it's plus. And if D2 is less than 0, it's minus. And so I'm not sure about this J20. Let's see what we've got here. I don't know why it says J20 there. That might be a mistake. Let's try this. I don't know why J20 got in there. But we corrected it. So if D2 equals 0, it's a 0. If D2 is greater than 0, it's a plus. If D2 is less than 0, it's a minus. So you're going to have either a plus, a minus, or a 0 in the sign. So then what you do is you count the number of negatives over here. So it's going to be count if E2 to E11 is a negative, and that's 5. You count the number of zeros. Count if E2 to E11 is 0. And then you count the number of pluses. So count if E2 to E11 is plus. And then you count the non-zero pairs. So count A, E2, E11 minus H3. So that's going to be 2 minus H3 is 2. So count A, E2 to E11 minus H3 is 2. So you're going to have 8 non-zero pairs. Our alpha, which is our significance level, is going to be 0.05. And then our expected probability is going to be 50%. And then we're going to calculate the p-value. So the p-value is calculated as binom.dist. H4 is 3. H6 is 8. And H8 is 0.5 and true. And that's going to give you your p-value of 36%. And then so basically what happens is if it's a null hypothesis, no significant difference between the standard treatment and the new treatment. And if it's an alternate hypothesis, you have a significant difference between the standard treatment and this new treatment. And since we have a 36%, we can see that it's above the significance level of 0.05. So that means you would fail to reject the null hypothesis. But we come over here to the interpretation, and if H10, that's your p-value, is less than H7, that's your alpha, reject the null hypothesis. Otherwise, fail to reject the null hypothesis. And so since 36% is greater than 5%, we failed to reject the null hypothesis. And then what we've done here is I have created a chart for you for the sign test, so you can see the values of the standard treatment, and you can see the values of the new treatment, and you can see that there is no significant difference between the standard treatment and the new treatment. But you can experiment with this sign test on your own. The sign test is one of the easiest nonparametric tests to do. So the next video is going to be on another nonparametric test. So I hope that you decide to watch it.